Rerouting old power cables can be a challenging task, especially when dealing with cables that are 40 years old or more. Several factors must be considered to ensure the safety and reliability of the electrical system. One of the primary concerns is the condition of the insulation. Old insulation tends to become brittle and prone to cracking or tearing, particularly when subjected to bending and movement. Over time, insulation can shrink and expand due to temperature fluctuations, which weakens the bond between the insulation and the conductor. Rerouting cables may also involve dragging them over rough surfaces or exposing them to impacts, which can further damage the insulation. If the cables have been exposed to harsh environmental conditions, such as moisture or ultraviolet radiation, the insulation may be further degraded. Given these potential risks, it is highly recommended to proceed cautiously and consider several steps. Firstly, perform a thorough inspection of the cables. Before moving the cables, carefully inspect them for any signs of damage, cracks, or imperfections. Use a flashlight and a magnifying glass to examine any suspicious areas. Secondly, test the cables. Perform electrical testing, such as insulation resistance and continuity tests, to ensure the cables are in good condition. These tests will help identify any potential issues before re-energizing the cables. Thirdly, use proper handling procedures. Handle the cables with care, using appropriate lifting equipment and techniques. Avoid bending them too tightly or subjecting them to excessive forces. Fourthly, provide additional support. As much as possible, provide additional support to the cables during rerouting, such as cable trays, cable ladders, or straps. This will minimize the risk of damage from their own weight or external loads. Fifthly, minimize the number of bends. Try to minimize the number of bends in the cables, as sharp bends can put stress on the insulation and potentially cause damage. Sixthly, use cable lubricant. If necessary, use a cable lubricant to facilitate bending and reduce friction. Finally, consider replacing the cables. If the cables are in poor condition or if the risks associated with rerouting are too high, consider replacing them with new cables. Additional considerations also include the time constraints of the project. Given a short shutdown window, it is crucial to plan carefully and allocate sufficient resources to ensure a smooth and safe rerouting process. Emphasize safety precautions throughout the process, including proper grounding, lockout or tag-out procedures, and the use of personal protective equipment. It is also important to maintain thorough records of all inspections, tests, and maintenance performed on the cables. This documentation provides evidence of due diligence and can assist in troubleshooting any future issues. When dealing with aged cables, it's also beneficial to understand the specific types of insulation used and their degradation characteristics. Common insulation materials found in older cables include rubber compounds, varnished cambric, and early forms of cross-linked polyethylene. Each material has its own set of vulnerabilities. Rubber insulation, for instance, can become dry and brittle over time, losing its flexibility and developing cracks. Varnished cambric, which consists of cloth tape impregnated with varnish, can also dry out and become susceptible to damage from moisture and mechanical stress. Early forms of cross-linked polyethylene may not have the same level of resistance to heat and environmental factors as modern formulations. When inspecting the cables, pay close attention to the condition of the outer jacket as well. The jacket provides a protective layer against abrasion, moisture, and chemical exposure. If the jacket is cracked, torn, or otherwise damaged, it can compromise the integrity of the insulation beneath. Another important consideration is the ampacity of the existing cables. Ampacity refers to the current carrying capacity of a conductor, and it is determined by factors such as the conductor size, insulation type, and insulation conditions. Over time, the insulation's ability to dissipate heat can degrade, which can reduce the cable's ampacity. When rerouting cables, it is crucial to ensure that their ampacity is still adequate for the intended load. If there is any doubt, consult the National Electrical Code, specifically Table 310.15. for ampacity correction factors based on temperature. As part of the electrical testing process, perform insulation resistance tests using a megometer, also known as a megger. This test applies a high voltage direct current to the cable and measures the resistance between the conductor and ground. A low insulation resistance reading indicates that the insulation is compromised and may pose a safety hazard. Continuity testing is another essential step. This test verifies that the conductor is intact and that there are no open circuits. Use a multimeter to measure the resistance between the ends of the conductor. A high resistance reading indicates an open circuit. When handling the cables, use cable rollers or other specialized equipment to minimize friction and prevent damage. Avoid dragging the cables directly on the ground or over sharp edges. Secure the cables properly to prevent them from shifting or rubbing against other objects. When making connections, use appropriate connectors and terminations that are compatible with the cable type and size. Ensure that all connections are clean, tight, and properly insulated. Follow the manufacturer's instructions for installing the connectors and terminations. When re-energizing the cables, gradually increase the voltage to allow the insulation to stabilize. Monitor the cables for any signs of overheating, arcing, or other abnormalities. If any problems are detected, immediately de-energize the cables and investigate the cause. Furthermore, consider the long-term maintenance of the cables. Implement a regular inspection and testing program to monitor the condition of the insulation and identify any potential problems before they become serious. Keep detailed records of all inspections, tests, and repairs. It's also important to consider the environmental impact of the cable rerouting project. Dispose of any scrap cable and other waste materials properly, following all applicable regulations. Consider using recyclable materials whenever possible. The number of bends in the cable is an important thing to consider. Bending radius is an important factor to consider, as exceeding the minimum bending radius can damage the conductors and insulation. The minimum bending radius varies depending on the cable size, construction, and insulation type. Consult the manufacturer's specifications for the recommended bending radius. In general, larger cables require a larger bending radius. For example, a 350 cm cable typically requires a bending radius of at least 12 times the cable diameter. In addition to the bending radius, also consider the bending angle. Sharp bends can concentrate stress on the insulation and conductors, which can lead to premature failure. Try to make gradual bends whenever possible. When installing cable supports, ensure that they are properly sized and spaced to support the weight of the cables. The support should be made of corrosion-resistant materials and should be securely fastened to the structure. Also, make sure that the cable supports do not damage the cable insulation. For example, avoid using supports with sharp edges or rough surfaces. Consider using cable ties or straps to bundle the cables together. This can help to reduce stress on the insulation and prevent the cables from rubbing against each other. When using cable ties or straps, do not over-tighten them, as this can damage the insulation. Also, use cable ties or straps that are compatible with the cable insulation. For example, avoid using cable ties made of materials that can react with the insulation. If the cables are exposed to sunlight, consider using a UV-resistant cable jacket. UV radiation can degrade the insulation over time, which can reduce the cable's lifespan. A UV-resistant jacket can help to protect the insulation from the harmful effects of sunlight. When working with electrical cables, always follow safe work practices. Energize the cables before working on them and use appropriate personal protective equipment. Be aware of the potential hazards associated with electricity and take steps to mitigate them. Replacing the cables may be the best option in some cases, especially if the cables are old, damaged, or have been subjected to harsh environmental conditions. Replacing the cables can provide a higher level of reliability and safety. If you decide to replace the cables, make sure to use cables that are rated for the intended application. The cable should be sized properly for the load and should have an appropriate insulation type. Also, make sure that the cables are installed in accordance with all applicable codes and standards. If there are several hundred 480 volts terminations splices, consider using prefabricated cable assemblies. This can help to reduce the amount of time required for installation and can also improve the quality of the connections. Prefabricated cable assemblies are typically manufactured in a controlled environment, which can help to ensure that the connections are made properly. When making splices, use appropriate splicing kits that are compatible with the cable type and size. Ensure that all splices are clean, tight, and properly insulated. Follow the manufacturer's instructions for installing the splicing kits. When working with transfer switches, make sure that they are properly rated for the intended application. The transfer switches should be sized properly for the load and should have an appropriate voltage and current rating. Also, make sure that the transfer switches are installed in accordance with all applicable codes and standards. Consider using a power quality analyzer to monitor the electrical system after the cables have been rerouted. A power quality analyzer can help to identify any potential problems such as voltage sags, voltage swells, or harmonic distortion. Monitoring the electrical system can help to ensure that it is operating properly and that the equipment is not being damaged. When working in a critical process area, it is essential to have a detailed plan in place. The plan should include a list of all the tasks that need to be completed, the resources that will be required, and the schedule for completing the work. The plan should also include contingency plans in case of unexpected problems. It is also important to communicate effectively with all stakeholders throughout the project. This includes the client, the contractors, and the plant personnel. Effective communication can help to ensure that everyone is aware of the project's goals and progress. In addition to the above considerations, also consult with a qualified electrical engineer or contractor to ensure that the rerouting project is performed safely and in compliance with all applicable codes and standards. A qualified professional can provide valuable expertise and guidance. In summary, rerouting old power cables can be a complex and challenging task. By following the recommendations outlined above and consulting with qualified professionals, you can help to ensure that the project is performed safely and reliably. And remember to document everything. Maintaining detailed records of all inspections, tests, and repairs is crucial for future reference and troubleshooting. This documentation should include photographs, test results, and any other relevant information. The documentation can be used to track the condition of the cables over time and to identify any potential problems before they become serious. It can also be used to demonstrate compliance with safety regulations and industry standards.